Using a ruler and a pencil and a pair of compass, construct a right angle triangle ABC with AB being 5 centimeters, the angle at B being 60, and BAC, the angle at A being, angle at A is 60. So what you're supposed to do is, you take out your ruler and you draw your line AB, and you need to make sure that AB is of course 5 centimeters. You would draw it with a ruler, of course. All right. And you make sure that AB is 5 centimeters. And then what you do is, of course, the angle at B should be 90. So don't swing up your arc and make the cross here. When you swing up your arc, it's supposed to cross here and here. And this is where you create your angle that is 90 degrees. This is the angle that should be 90. It's the angle at B. It says ABC. That's the key thing, guys. This angle should be 90. All right. Of course, again, I don't have the materials to do this so nice. But this is a rough sketch of what you should have. That should be 90 right here when you swing up your arcs. All right. And then, of course, the angle at A, BAC. BAC means this angle. The angle right here should be 60. So that means when you create the triangle, this angle right here should be 60. This angle in here should be 60. In here, so this angle is supposed to be 60 degrees. All right. So that means that when you open your compass and you swing an arc and you go to the other side and you swing your arc, this angle is supposed to be 60 degrees. All right. Just make sure you draw your triangle quite accurately. All right. So that's just for geometric construction. Go over your notes on how to do geometric construction, how to swing your arcs and stuff like that. Easy question. These are giveaway marks, all right? Giveaway marks. But that's the basic idea of what you should have. I find that a lot of persons, they don't even know which angle should be the 90. When you say angle ABC, the angle at B should be 90. That's what I want to stress on. A lot of persons, they know what to do for construction, but they don't interpret the question correctly. It's the angle at B that should be 90. This right here is saying the angle at A should be 60. That's the important takeaway. And AB should be 5 centimeters. All right, off geometric construction and onto something that involves a little more calculating. It says, the diagram below shows a right angle triangle with sides A units, B units, and C units. Express C in terms of A and B. Now, express C in terms of A and B. Can do that multiple ways, but I'm thinking they're talking Pythagoras theorem. Because we know from Pythagoras theorem that A squared, which is opposite square plus adjacent square, is equal to the hypotenuse square. But then they want C to be the subject. So we square root both sides to say C is equal to the square root of the opposite square. C is equal to the square root of A squared plus B squared. All right, good. Now it says, write in terms of A, B, and C an expression for sine theta plus cos theta. Now, first and foremost, sine theta, SOHCAHTOA, S-O-H, SOHCAHTOA. So stands for opposite over hypotenuse. So the opposite is A, the one that is the side that is opposite from the angle. That's A over the hypotenuse is C. And then they want cos theta, so katoa. Cos theta is going to be equal to, cos theta is adjacent B over hypotenuse C. And so therefore what we're saying then is sine theta plus cos theta is equal to A over C. Sine theta plus cos theta is equal to A over C plus B over C. That's all we're saying. Sine theta plus cos theta is equal to A over C plus B over C. That's all we're saying. No, that's that. Nice and easy. Now it says, using the results from 1A and B, show that sine theta square plus cos theta square equal 1. So using both of these results, so pretty much they're saying, using this result and using this result, show that sine theta all square plus cos theta all square is equal to 1. Okay, so to do this, it says using both results. The first thing is I noticed that we have sine theta plus cos theta, sine theta plus cos theta, writing this down, sine theta plus cos theta. We said that sine theta plus cos theta is, what was that? A over C plus, I think, B over C. All right. Now we notice if we're to square sine theta, so what we're saying now is that sine square theta, follow me, sine square theta plus, all right, let me not write it as sine square theta. Some person might wonder, why did I put sine square theta? Don't worry, you'll get used to it in that way in ADMATH and CAPE-math. So write it as sine theta square plus cos theta square. That's going to be equal to, now look at this now. Sine theta square is going to be equal to, squaring this part becomes A square over C square. A square over C square. Plus cos theta going to become B square over C square. So that's sine theta square plus cos theta square. It's A square plus B square over C square. Now this is equal to, now we can write this as one fraction as A square plus B square. And this is all being divided by C square, writing it as one fraction. But guys, look. From part A, we said this. We said that C square is A square plus B square. And so A square plus B square in the numerator is C square. This A square plus B square is C square. So we get C square over C square. Any number divided by itself is 1. And so we've shown that sine square theta plus cos square theta is equal to 1. So in conclusion, sine theta, when it is being squared, plus cos theta, when it is being squared, is equal to 1. So that's how we show this. Nice and easy. This is known as a trig identity that is very powerful in CSEC math, CSEC ADMATH that is, and CAPE math. Very powerful. You're going to see this a lot.